Hello students, let us continue the next part of the topic excretion, where there is a mechanism called countercurrent multiplier phenomena, by which urine is becoming hypertonic, blood is getting all the essential elements which it is losing during glomerular filtration, and body will get rid of all nitrogenous waste. So here, as afferent arteriole takes the blood towards the glomerular capillaries for filtration, after filtration the blood vessel which collects the blood from the Bowman's capsule is efferent arteriole. So efferent arteriole will take the blood, and from the renal cortex it will extend into renal medulla. The name of this blood vessel is vasa recta because this blood vessel is now in between the Henle's loop, a region in the renal medulla. It gives profuse network of the blood capillaries around the Henle's loop, forming peritubular network. So peritubular blood capillaries are efficient in receiving all the components which are taken out from the nephric filtrate, by this countercurrent multiplier mechanism. Here, the meaning of this countercurrent is, when a fluid is passing down, then the blood is passing up. Means the nephron's tubular region taking the filtrate in downward direction, at the same time the blood capillaries taking the blood in upward direction. Opposite side, the tubular region taking the filtrate in upward direction, where the blood capillaries through which blood is flowing in downward direction. So different fluids in the same region transported through the tubular regions of nephron and the blood capillaries will show opposite flow. This is essential to maintain the osmolarity. This is essential to take up all the essential components from the interstitial fluid after selective reabsorption. This is also essential in releasing toxic elements back to the interstitium for elimination. Now, as PCT through which filtrates start moving, it helps in selective reabsorption of nutrients, electrolytes like sodium chlorides and bicarbonate ions. At the same time, it receives H plus and NH3 plus. When it starts coming down, it loses H2O along with bicarbonate ions, and it also receives some ammonia molecules. When it passing up, it loses maximum potassium, sodium. It is completely reabsorbed. At the same time, ammonia molecules, H plus ions are entering. So it is a continuous exchange of these elements from fluid to filtrate, filtrate to fluid. In between, the blood capillaries are taking the blood in opposite direction to the direction of the filtrate. Let us consider first Henle's loop. Filtrate passing down, which is hypotonic. It is made hypertonic by selective reabsorption of water, and when filtrate passing up, this limb is diluting segment where it is allowing electrolytes to reabsorb, and the two flows of same Henle's region showing downward movement and upward movement. This is countercurrent. The upper downward region is permeable to water, upward region is permeable to electrolytes. At the same time, vasa recta giving the blood capillaries, when filtrate is going down, the blood capillaries are taking blood in upward direction, means whatever essential elements are reabsorbed from the tubular regions of nephron, who will take them? Blood. That's why the nature of the fluid surrounding the nephron and filtrate flowing into the nephron remains in proper concentration, which will help in augmentation, making the urine more and more concentrated. Here, we should not forget that the entire mechanism of urine formation is under the control of a region called medulla oblongata. In medulla oblongata, there are vasomotor centers. These vasomotor centers are stimulated due to fall or increase in the blood pressure. Decrease in the blood pressure and increase in the blood pressure is detected by the receptors present in each and every cell. So fall in the blood pressure will affect glomerular filtration. Then the urine production will decrease. Increase in the blood pressure, by which selective reabsorption of water may be affected and body start losing more and more water. So by feedback mechanism called as renin-angiotensin mechanism, this process is completely regulated under the influence of medulla oblongata. Okay, imagine the glomerular capillaries are experiencing less blood pressure. When blood pressure is less, means incoming blood is less, naturally filtration is affected. That time, the juxtaglomerular apparatus, which are holding afferent arteriole and one limb of the DCT, will secrete a hormone called renin. This renin is secreted in the blood. It is a vasoconstrictor. It stimulates. So renin secreted in the blood carrying one protein called as angiotensin. It is in inactive form. So it is converted into angiotensin 1 and angiotensin 2. As angiotensin 1 and angiotensin 2 start activating, the blood vessels start contracting. So diameter becoming less. So naturally blood which is flowing in this capillary, because of the constriction, the pressure is increasing. So because of vasoconstriction, blood pressure start rising. This stimulates adrenal gland. It is an endocrine gland located above each kidney. Adrenal cortex secrete a hormone known as aldosterone. This aldosterone also act as a vasoconstrictor. So more and more contractions of the blood vessels, increasing the blood pressure, by which glomerular filtration will continue. As glomerular filtration rate is higher, it allows less reabsorption of water because there is no enough time available for osmotic movement of the water. Then body start losing more water, urine production increases. It should not happen. Plus, the blood vessel, when they remain in constricted condition, the heart pressure will increase. So it is dangerous for the heart functioning. That's why when vasoconstriction continues for efficient glomerular filtration, where body start losing more water through urine, that time atrium, it is the upper chambers of the heart, atrial wall secretes a protein known as atrial natriuretic factor, ANF. So when this ANF is secreted due to increased pressure on the heart wall, this will dilate the blood vessels, exactly opposite mechanism. So due to vasodilation, blood pressure slowly decreases. When it goes below normal, again angiotensin is activated, known for vasoconstriction. When blood pressure increases, release of ANF, vasodilation. When blood pressure decreases, again angiotensin for constriction. By this, angiotensin for constriction and ANF for vasodilation. Due to these two feedbacks, the urine formation is always regulated. Apart from this, one more thing you need to remember. The amount of blood filtered through glomerular capillaries in 1 minute is known as GFR. So if we want to diagnose the renal functioning, then we have to find out GFR, glomerular filtration rate. If it is proper, then there is no problem with the kidney functioning. If anything is infected in the kidney or if any abnormality is there in the kidney, GFR is showing abnormal values. It indicates that kidney functioning is not proper. So in 24 hours, approximately 180 liters of blood is filtered through all the nephrons, and the result is in 24 hours 1.5 liter of urine is produced. See the values. 180 liters of blood is filtered, and it is not at a time, in 24 hours time span, and 1.5 liter of urine not at a time, in 24 hours simultaneously it is produced. Means the values indicates that the amount of water reabsorbed, amount of nutrients reabsorbed, and amount of electrolytes reabsorbed. So whatever is essential, the tubular region, they don't allow it to eliminate. Thus, the GFR, if it is not proper, then it may leads to some disorders. There is one disorder where the renal functioning is affected. If it is reversible by treatment, then we call it as chronic renal failure, and if it is not reversible, it is permanent damage to the kidney, then it is called acute renal failure. For renal failure, there is only one remedy. We need to put the patient on dialysis. It is a treatment given to renal failure where there are two methods. One is hemodialysis and other is CAPD, continuous ambulatory peritoneal dialysis. In hemodialysis, patient has to be admitted in the hospital. Through artery, blood is pumped out, added with the anticoagulant heparin. Then it is freezed at 0 degrees Celsius, and this blood is allowed to flow through the dialyzing machine. It is artificial kidney, a machine which will help in filtration of the blood. In that machine, there is a compartment filled with the dialysate. It contains all nutrients, electrolytes necessary for the body, but it is devoid of nitrogenous waste. Here the dialyzing tubes are immersed in the dialysate. So when blood is flowing into this dialyzing tubes, the wall of the dialyzing tubes made up of cellophane paper, which is selectively permeable membrane, through which all waste molecules will diffuse out. And if blood needed some nutrients and electrolytes, it can easily take from the dialysate. So the blood which is coming other side of the dialyzing machine, it is filtered blood. It is warmed up to body temperature, and then it is allowed to enter in the vein. So there are two incisions in the patient's body. One to take out the blood from the artery, and another incision to give the filtered blood in the vein. Thus, for one dialysis, 6 to 7 hours time is necessary, depending upon the condition. The dialysis is repeated either twice in a week or thrice in a week, right? If the parameters are normal, it is possible. If person is healthy, then the person can be put on CAPD. Okay, this we'll study in some other session. Due to more reabsorption of water or less intake of water, there are some salts accumulating which are converted into oxalate crystals. This is going to hamper or blockening of the tubules. This we call renal calculi, generally we call renal stones. Due to infections, the glomerular capillaries show inflammation. So inflammation of the glomerular capillaries we call glomerulonephritis. So at the end of this topic, there are 3 disorders. Renal failure can be treated with hemodialysis. Renal calculi, these are kidney stones, accumulation of the salts containing calcium oxalate or potassium oxalate. They may be forming in the kidney, in the ureters, in the bladder, right? And renal glomerulonephritis. Okay, with this, let us conclude the topic excretion, elimination of nitrogenous waste from the body with the help of excretory system. As human is ureotelic, we excrete urea in the form of urine, and this urea is filtered along with the water in the nephrons, which are located on the walls of renal pyramids, which are present in between renal cortex and renal medulla. Thus, the topic excretion is concluded here. Thank you very much.